Evaluate the exact value of sine of theta over 2 if tangent of theta is negative 5 over 12, where theta is in the fourth quadrant. Since the input of sine is an half angle, we will use the half angle formula for sine. The half angle formula for sine of theta over 2 is plus or minus the square root of 1 minus cosine of theta in the numerator divided by 2. If we know what cosine of theta is, we can plug it in and evaluate this. But first, we should take care of the plus or minus sign. We were given that theta is in the fourth quadrant, meaning theta is between 3 pi over 2 and 2 pi. To obtain theta over 2, we simply divide it by 2, but if we divide it by 2 one part, we have to divide it by 2 every single part. Theta over 2 is therefore between 3 pi over 4 and pi. If an angle is between 3 pi over 4 and pi, then that angle is in the second quadrant. Theta over 2 is in the second quadrant. Sine of theta over 2 is positive, so we can drop the plus or minus. Sine of theta over 2 is 1 minus cosine of theta over 2. We then set out to find tangent of theta. Theta is in the fourth quadrant, so y is negative and x is positive. We draw a right triangle, label the angle theta. Tangent of theta is opposites over adjacent. For convenience, we let the opposite be 5 and the adjacent be 12. The hypotenuse square is therefore 5 squared plus 12 squared. This is 25 plus 144, which is 169. The hypotenuse is the square root of 169, or 13. So tangent of theta is negative 5 over 12, give us this right triangle. From this right triangle, we see that cosine of theta is plus or minus for now, adjacent over hypotenuse, but in the fourth quadrant, cosine of theta is positive, so cosine of theta is 12 over 13. We then plug 12 over 13 into this expression. The square root of 1 minus cosine of theta is now 12 over 13. Don't forget, the 2 is still in the denominator inside the radical. In the numerator, the denominator is 13. So we write 13 and multiply 13 over 13 to 1 to get the common denominator. 13 over 13 minus 12 over 13. In the numerator, it is now 1 over 13, and we still have 2 in the denominator. This is the square root of 1 over 13 times the reciprocal of 2 is 1 over 2. This is the square root of 1 over 26, or simply 1 over the square root of 26, or the square root of 26 over 26. We're now done with the problem, but the way that we drew the right triangle is questionable. We know that theta is in the fourth quadrant, so a better way to draw the right triangle is having the right triangle below the x-axis, with the opposite side to the angle theta is 5 and the adjacent 12. The x-coordinate at these endpoints is 12 and the y-coordinate is negative 5. This is because this point is in the fourth quadrant. where x is positive and y is negative. The hypotenuse is always positive. So when we use the right triangle approach to write the trigonometric ratio for cosine, cosine is x over r. X is positive 12 in this case, and r is always positive. And that is why we have cosine of theta equals 12 over 13. We could also argue that theta is in the fourth quadrant, so cosine of theta is positive.